All right, chapter 9, problem 3. Here we have two children pulling on opposite sides of a door. Um, Both push horizontally and perpendicular to the door. So if you imagine the door hinges are here, here's the door. One child is pushing this way, the other child is pushing that way. Um, so one child pushes with a force of 17.5 newtons and a distance of zero point 0.6, right? And the other child pushes with some unknown force at the moment, but a distance of 0.45. So the question is, what force must the second child exert to keep the door from moving, assuming friction is negligible? Right? All right. So we're going to call the hinge the pivot point. And so what we're going to do is the sum of the torques. And so if you look, as I've drawn it, the torque from the first child is counterclockwise and therefore positive, and the force torque from the second child is clockwise and therefore negative. All right, but if we just write it, the torque from the first child, right, 1 plus tau 2 is going to have to equal 0. And the torque from the first child is 17.5 newtons times 0.600 meters, right, plus F. Now, we know the torque from the second child is going to end up having to be negative. That's okay. F is going to end up being negative, which means it's going to be pointing to the left rather than the right. So F times 0.450 meters equals 0, right? We solve for F. F is minus 17.5 newtons, right, times 0.600 meters divided by 0.450 meters. Okay, let's take a look and see what that is. 17.5 times 0.6 divided by 0.45. So 23.3 minus 23.3 newtons. All right, minus 23.3 newtons, that's the force. That means minus, I type 0, minus 23.3 newtons. That means the force exerted by the second child is to the left. All right, that's it for problem 3.